So quiz Monday. Just on 8.4. And then our test is going to be Wednesday next week on what the test was supposed to be on Monday. We're just going to do a little solo quiz Monday on 8.4, and then test will be 8.1 through 8.4 on Wednesday. So we did number 1 yesterday. Let's do number 2. Determine whether the function's even, odd, or neither. What do we have to do to determine if it's even, odd, or neither? Remember, we plug in a number and its opposite. So a good number to plug in would be like 2 and negative 2. So we plug in 2, we get 2 times 2 minus 5. Make sure you follow your order of operations. So we have 4 minus 5, and what's 4 minus 5? Negative 1. Now let's do the same thing with negative 2. We have 2 times negative 2 minus 5. What's 2 times negative 2? 2 times negative 2. Negative 4. And negative 4 minus 5? Negative 9. Did we get the same number or opposite numbers? No. So what would our answer be if they're totally different? Neither. Questions here? Let's do 3. So again, we're plugging in the same number and its opposite. So let's plug in 2 and negative 2. So we have 2 times 2 squared plus 5. What do we have to do first here according to PEMDAS? Parentheses, but we don't have any math going on in the parentheses, so then what? Exponent. What's 2 to the second power? 4. And 2 times 4? And 8 plus 5? 13. Let's do the same thing with negative 2. So we have 2 times negative 2 squared plus 5. So again, we have to do the exponent first. What is negative 2 to the second power? Negative 2 to the second power. Positive 4. And 2 times 4. And 8 plus 5? 13. Did we get the same answer, opposite answers, or neither? Same. So what does that tell us? Even. Remember, if we get the same numbers, it's even. If we get opposite answers, it's odd. And if we get totally different numbers, then it would be neither. So our answer here is even. Yesterday we did the graphing ones. We said if it's symmetrical on the y-axis, it's even. So even is if it's symmetrical. Odd is if we flip them upside down, we get the same picture. And then neither would just be not symmetrical and not able to be flipped. So we said that the first one was even because it's symmetrical on the y-axis, and the second one was neither. All right, for 6 through 8, I think we did 6 together yesterday, so let's do 7. We want to find the vertex and the axis of symmetry. So vertex is what we're adding on the inside and what we're adding on the outside, but we have to remember to do what? Flip the sign on the inside one. So what would our vertex be? 3, 0. Awesome. And then what is our axis of symmetry? X equals 3. Awesome. Don't forget the x equals for the axis of symmetry. And then let's do number 8. So what we're adding on the inside and what we're adding on the outside, but we change the sign of the inside. So what would our vertex be? -7, 0. Perfect. And what is our axis of symmetry? X equals -7. Awesome. All right, we did 12 together in class. So let's do 13. Here again, we're finding the vertex and the axis of symmetry. So the vertex is what we're adding on the inside and what we're adding on the outside, but we changed the sign of the inside. What would our vertex be here? Awesome. Our vertex would be 2, 5. Perfect, because we changed the sign of the inside one. And then what is our axis of symmetry? x equals 2. Perfect. What about 14? What's our vertex? -5, comma -4. And what is our axis of symmetry? X equals -5. And this question doesn't ask for it, but for this one, let's identify our transformations, just for practice. What is a negative out front of our graph, or multiplied out front due to our graph? No. Well, it does mean that it opens down, yes. But what's the word that we know to use for that? What are the vocab words? Mia, take a seat. What do we call that when it flips upside down? Our graph opens down. Starts with an R. Reflection. Awesome. A negative means that we have a reflection, which means that our graph is going to open down. When we multiply by 3, what does that do to our graph? Just remember, when we multiply by a number, it's either a stretch or a shrink. What does 3 mean that it's going to be? A stretch. Awesome, because it's greater than 1. And then when we add 5 on the inside, so let's think about our graph. Our vertex is at -5, -4. So we go to the left 5 and down 4. So what does adding 5 on the inside do to our graph? Moves it which way? Left 5. Awesome. Left 5. And then subtracting 4 on the outside? Down 4. So on the next page, we are describing the transformations and graphing. So let's start by finding our vertex and axis of symmetry first. For number 9, what would our vertex be? -1, comma 0. And then what's our axis of symmetry? X equals -1. So when we graph that, we're going to go to the left to -1 and stay at 0. Our axis of symmetry goes right through it. It's a dotted line that goes right through the middle. And then how do we know what the rest of our graph is going to look like? What do we need to do? So to graph, we want to plug in a number. Awesome. Plug in a number close to the axis of symmetry. What's a number close to -1? -2. What's another number close to -1? 0 would also work. Yeah, either one of those would work. Let's plug in -2, since that's what you guys said first. So -2 plus 1 squared. So we plugged in -2 for our point. I'm going to put it down here. We picked -2, so that's going to be our x. We plugged that into the x. Now let's solve this to get our y, or our g of x. So what's -2 plus 1? -1. And what's -1 squared? 1. And 2 times 1? 2. So we plugged in -2 and got 2. So we're going to go to the left to -2 and up 2. So now that we have a point on the left side of our line, what does that mean? Do I need to plug in another number? We're going to have the same exact point. So since we're one space away on the left, we're going to have the same point one space away on the right. So remember, our axis of symmetry is a mirror. We got the same thing on the left and the right side. So once we have our 3 points, we can draw our parabola. Remember, it's going to be a U shape. If it opens up, it's a U. If it opens down, it's an upside down U. It's not a V. It's not a straight line. It's not a squiggly line. It's a U. Any questions here? All right, let's describe our transformations too. So when we multiply by 2 out front, what does that do to our graph? Chloe, what does multiplying by 2 do to our graph? What does it do? stretch. And then when we add 1 on the inside, look at our graph that we just plotted points for. Which direction does that move our graph? To the left. Perfect. We went to the left 1. So typically our vertex starts at 0, 0. But when we add or subtract numbers, it'll shift it. So here our graph got shifted to the left 1. Any questions? All right, let's go to the bottom and do 15. So first thing we want to do is, actually let's do 16. I like 16 better. First thing we want to do is find our vertex and our axis of symmetry. What would our vertex be? -2, -4. Awesome. So let's plot that. We go to the left 2 and down to -4. What's our axis of symmetry? X equals what? -2. So our axis of symmetry is a dotted line that goes right through it. Now, how can we find another point on our graph? What should we do? We want to plug in a number that's close to what? Close to the axis of symmetry. What's a number close to the axis of symmetry? Sure, -1. So the x in our vertex, Chris, is -1. How do we find the y? Or the x in our point, not our vertex, but the x in our point is -1. How would we find the y? So we picked -1 to find another point. What do we do to find the other half of our point? We picked -1. How do we find the other half? What do we do with the number that we picked? What do we do with the number that we picked? Anybody? We have to plug it into the equation. So we have -1 plus 2 squared minus 4. What do we have to do first? The parentheses. So we have negative. What's -1 plus 2? 1 minus 4. Again, we have to do the exponent next. What is 1 to the second power? 1, but we still have that negative outside. So what's -1 minus 4? -5. So we plugged in -1 and got -5 as our other point. So we're going to go to the left to -1 and down -5. How do we know where our third point's going to be? We could plug in another number, but what's easier? Same thing on the other side. We know that our axis of symmetry is a mirror, so we can just have the same thing on the other side. Once we have our 3 points, we can draw our parabola. Now let's identify our transformations. What does a negative out front do to our graph? Reflection. Awesome. It means that it's going to flip upside down, so it's going to be a graph that opens down, which we already saw that because we just graphed it, but it is a reflection. What does a +2 on the inside do to our graph? Perfect. We went to the left 2. And then what about -4? Down 4. Awesome.